Okay, this video is going to be a review of Unit 1, and we have been looking at equivalent fractions, decimals, and percents. Let's take a look at a couple student expectations. 6.4G tells us that we need to be able to generate equivalent forms of fractions, decimals, and percents using real-world problems, including problems that involve money. And this is considered a readiness standard. This means in 6th grade you should be prepared, fully prepared to work through problems that fall under this expectations being fractions, decimals, percents in real-world problems. Also, 6.4E says to represent ratios and percents with concrete models, fractions and decimals. This is called a supporting standard. We're just supporting future work that we'll be working on as in 7th grade and moving on. This is something that we're introducing this year. So let's take a look at review number 1. It says that Jason's soccer team is raising money for a tournament in Florida. The team has raised 2/5 of the money needed to pay for the trip. We have two parts. Part A wants us to create a diagram to represent the percent the team has already raised. And then Part B wants us to represent the percentage that remains to be raised as a fraction and decimal. Now, again, in Part A, it wants us to determine the percent that has already been raised. Well, we've been given the part as a fraction. It says the team has raised 2/5 of the money. So we need to be able to understand what 2/5 is as a percentage. Now, and we also need to be able to represent that using a diagram. So let's go ahead and do that. I will try to draw a diagram here. Well, that got a little out of hand. Let me try that real quick. Maybe a little straighter. Not really. Okay, so 2/5 in the diagram. And remember, we're just asked about the percentage. We're not given the actual money in this. So our diagram actually represents 100% of what we're trying to raise. So, but again, we're given it in a fraction form of 2/5. That means our diagram needs to be in 5 equal sections because we've raised 2/5 of the necessary money. So if all 5 sections add up to 100%, then basically we need to divide 100 by 5, and when we do that, we're going to get 20. So basically what we understand is that each section is worth 20%. And very specifically, the numerator says 2/5 has already been raised. That means we could highlight the 2/5. That would be the first 2 sections. And if you have 20% and another 20%, you have a total of 40%. So we understand that the team has already raised 40% of the money needed for the trip. Now, we could look at this in fraction form, and I taught you a couple ways. We could just divide up to determine, we divide 5 into 2, and we will get 0.4, which is also 40%. We could have looked at equivalent fractions. 2/5 is equal to 4/10, and of course 4/10 is equal to 40 out of 100. And anytime you have a number out of 100, you have a percent. So the top number is the percentage, 40%. Regardless of how we take a look at this, this example is wanting us to use the strip diagram. So we see with the strip diagram that 40% of the money has been earned. Now, Part B wanted us to represent the remaining percentage that needs to be raised as a fraction and a decimal. I'm going to erase this real quick right here. What I want to look at is what remains, and that is these 3 out of 5 sections, which is a fraction of 3/5. But we can also just take a look. If we have 20%, 20%, and a third 20%, then we have a total of 60% that remains to be earned. Again, as a fraction, we can see that it's 3/5. You may understand that as 6/10 or 60 out of 100. It all says the same thing, but our diagram was in fifths, so our fraction then would be 3/5. And you may understand if you already have 2/5, then what remains is 3/5 in order to have a whole of 5/5. Okay, that takes care of number one. Let's take a look at another review problem. This one says that Alicia's homeroom class is collecting money for a class party. Her class has already collected 30% of the $400 needed for the party. Use a strip diagram to determine the amount of money the class still needs to collect for the party. Okay, the information that is given is that the class has already collected 30% of the $400. So the total the class needs is 400. The part that they've already raised is in percentage form, and it is 30%. So let's go ahead and start with a diagram to represent that 30%. To see then if we could figure out how much money the class still needs for the party. Okay, so let's draw a diagram here. And remember, this diagram now will represent the amount of money the class needs. Well, all of it, or 100% of it, would be the $400 that the class needs. All right, $400. Now, the fraction that was given to us, or I'm sorry, the percentage that was given to us is 30%. Well, we understand percent means 30 out of 100, so this is an equivalent fraction of 30 out of 100, 30%. Well, let's go ahead and simplify that by dividing by 10. So now we have a fraction of 3/10. So therefore, we need a diagram of 10 equal sections, and we're going to look at 3 of them. So let's go ahead and draw our diagram. Try to do the best we can for 10 sections. Let's see, 1, 2. Okay, so we have 10 sections. Well, if all 10 sections equal $400, then we're going to divide 400 by 10. And maybe some of you might be able to do that in your head, but if we divide 400 by 10, let's see, 10 goes into 40 4 times. We no longer have a remainder. We do have to bring down our final 0, but of course 10 goes into 0 times, so it looks like 40 will be the amount for each section. Now this is not 40%, this is actually $40. If we create a model in tenths, then we have 40 for each section. This may seem like a lot of work, but I'm trying to help you understand what percentages are. 30% is 3/10. So the 3/10 then would be how much? It would be these 3 sections, or we could say 40 times 3, which equals $120. Well, the question specifically said how much money remains. Well, that's all that's left right here. Well, that's again $40, but that's times what the 7 sections that remain, or 7/10. Remember, if we have 3/10 already, then we would need 7. I'm sorry, I wrote that wrong. 3/10. We would need 7/10 to equal 10/10 as a whole. So that's where the 7/10 comes from. 40 times 7. We'll go ahead and work that out for you. 40 times 7 is 280. So the class still needs to raise $280 for the trip. And that is a quick review of Unit 1.